Alright. And then, okay, and in the last video where we left off was, well, we left off right at our star. And we had just come to the point where we decided that our star and everything that we consider our star and everything that is gravitationally held to our star is 1 light year across. And we had just mentioned actually Alpha Centauri, which is the next thing we're going to talk about, and that is the very closest star to us. So let's go ahead and wipe this clean. And alright, here's our sun, we'll say. Or here's our star. And this would be all of our Oort cloud. Which, I hope I'm not writing that backwards. Whatever. I'm not going to try to spell. Okay, this is our star, and it's the Oort cloud. And everything we consider our star. And then right over here, we'll say, is Alpha Centauri. And there's actually A, B, and just Centauri. And it's a group of 3 stars that are pretty close to each other. But the very closest one is Alpha Centauri. And then, remember, this is 1 light year across, but the distance from our sun to this star, Alpha Centauri, this distance is actually 4.2 light years. So think about that. Think about what that means. This is all just vacuum and space. I mean, there's things out there, particles and this and that, but really most of this space between stars is just vacuum, empty space. It's 4.2 light years to the very closest star, the very closest one to us. So this is what kind of changed my idea about I've always believed in alien life form, you know, and this and that. And don't get me wrong, I still definitely believe in life in the universe, and I always will. I mean, there's trillions of stars, and there's definitely life equal to us and past us and not as advanced as us. I believe all of that, you know. But when I learned about the distance scales of the universe and kind of learned about the laws of physics, it kind of led me to believe that I don't believe we'll ever see an alien race. We may make contact, but even that would be difficult, because think about this. Alright, this is Alpha Centauri. It's the very closest star to us. Alright? If we sent a message from Earth, and we send it out at the speed of light, you know, we send a radio message, whatever, and it comes out and we say, "Hi, how are you?" Hi. Alright, we send it out. It's going to take 4.2 years to get there. When it gets there, if they're advanced and they, you know, send it right back and say, "Hi." Sorry, it's whatever. But they send it back. It's going to take 4, and that's if they send it right when it gets there. They send it back. It's going to take another 4.2 years. So for us to say hi to them and them to say hi back, and so we'll send a message, it would be 9 years almost. I don't know. It would take 9 years. 9 years for us to send a message and get one back if they sent it right back. And that's at the speed of light. You can't even move single particles to the speed of light, let alone full bodies and massive objects. Not even close. I mean, we're talking in the thousands of miles. We're talking at the speeds, even if we were 10 times as fast as what we can do right now, it would take 100,000 years to travel this distance to the very closest star. But anyway, so that gives you an idea of how much empty space there is in space. I guess, you know, that's why it's called space. That's a good name for it. But I mean, to the closest star, 4.2 light years, okay? Now, we're going to jump out to a huge distance, and basically, we're going to jump out to our galaxy. And this is a horrible depiction, but oh well. I guess I better make it kind of... Well, that's really bad. Whatever, it doesn't matter. Alright, and we have Orion's Spur, which is right here. We're probably about right here. This is where I would say we are. Oh, I need to quit trying to write. It's pathetic. Okay, right here on an Orion spur, which is kind of towards the outer edge of our galaxy, which is actually the Milky Way. If I don't think about it and I just write, it works. When I try to think about it, I get messed up. Alright, it's actually the Milky Way galaxy, and it's roughly about a huge distance. It really is. I mean, this is our little section, and these are all spiral arms. Man, that's really bad. I don't know how to do it. But anyway, it's roughly 100,000 light years across and about 2,000 light years thick. So it's kind of shaped like this. Sorry I drew it really badly, but it's kind of shaped. It's a spiral galaxy that's kind of shaped like a disc. From here to here is roughly about 2,000 light years, and this distance to this distance is roughly 100,000 light years. And there's actually about 200 billion got that? 200 billion stars in our galaxy, or more, you know. And and again, in a photon emitted from here would take 100,000 years to reach over here. That's how big this thing is. And if you emitted one from the bottom to the top, that would take about 2,000 years. So, okay, remember our sun, Alpha Centauri, 4.2 light years between stars, and there's 200 billion stars in this galaxy, this Milky Way. And what you're going to find out now, even in the next videos, is that even this distance that's unfathomable and not even I mean, you can't even imagine, is really small. But a fact that I think is crazy about this is that everything's moving. We're moving around the galaxy, you know. The sun and our star is orbiting this galaxy, and it takes about 230 million years for our star to circumvent the galaxy. That's how big it is. It's moving at extremely fast speeds, but it takes about 230 million years for our star to make its orbit around our galaxy that is actually the Milky Way, and it's 100,000 light years across. There's over 200 billion stars in it, and what you're going to find out in the next videos is that this distance is just scratching the surface. It's going to get really ridiculous.